Algebra, Miss Frisch here. So let's start off chapter 4. We are graphing some more, but now instead of just graphing, we're also going to be writing equations. So today we're starting with writing equations in slope-intercept form, which is convenient because we last talked about slope-intercept form. So our essential question is, how do I write equations in slope-intercept form, which is the y equals mx plus b? So I just want to remind you, we know what it is, and I've color-coded mine, so my slope is green and my y-intercept is yellow. Yellow y. I like to do that for my brain. So first thing we want to do is we actually want to figure out what our y and what our b is. Remember, this y-intercept is actually a coordinate point. It's the point 0, and in this case, it's -4. Okay, so I want to remind you, that's actually a point. It is a point. It's on the graph. It has an x-coordinate and a y-coordinate. And because of that, we actually know what our intercept is. So we can figure out our slope from this, and we can figure out our intercept. So I know my m is 3/5, and my b is -4. So I'm just going to write down here y equals mx plus b. And what I'm going to do is substitute in the values that we have. So for my m, I'm going to substitute in 3/5. My x and my y just stay. Okay, they don't move, they don't do anything, they just hang out. And then I want to plug in a plus -4. Now, one thing I want you to be careful of is when you have this adding a negative, right, we can rewrite that so that we have y equals 3/5 x minus 4. So this is the equation of the line with the slope 3/5 and the y-intercept at -4. So now let's try this one over here. Again, color coordinate it for yourself. So we have our y-intercept and we have our slope. Ooh, shifted it a little bit. Sorry about that. So I'm going to take my equation right here, my y equals mx plus b, and I want to plug in what I know. Well, my slope is -1/4. So I'm going to plug in y equals -1/4. My x just stays, right? X and y just stay. And then my b is a 5. Now be careful, what kind of a 5 is it? +5. So I need to add 5 to that. So that is the equation of this line. And I will add my colors on there for good measure because it helps our brains. All right, now that we know how to write those, there's actually some questions in the student journal on page 99, numbers 1 through 6. I would try a couple of those out. So pause the video now, try a couple out, see how you're feeling about it. We're also going to do a couple during our meets. So now that you've done that, using graphs to write equations. So instead of being given the slope and the intercept, we actually have to write the equation. So we've got our graph right here. Hopefully it's okay. It's a little grainy, I know, but hopefully you can read it. Up here is a 4, here's a 2, this is -2, this is -4. We want to read this graph. So we're going to start by finding our y-intercept. That is always the place to start. Okay, start with what b is. All right, start with finding your b. And it is right here at 2. So in this case, we have the point 0, 2, which means our b is 2. The next thing I'm going to do is I'm going to find the slope. If you like to find the slope first, that's fine. There's 2 key steps, right? I like to start with my y-intercept because it's easy to see. Slope takes a little bit more for my brain. So I'm going to find the slope next. And that's going to be our m. Remember, m is rise over run, right? It's rise over run. I've got it over here too. So I'm going to do my rise in the orange. Now here's what's really tricky. Okay, it's really tricky. You want to find a pretty point. I like to call them star points, but I played Mario games back in the day, so stars are a good thing. But you have our little markers for the x values and the y values that run up and down, and where the line perfectly touches them. Okay, so like this guy right here. And inside there, if I just blow it up nice and big, it makes a little star. Do you see that? How it's got an up and down, a sideways, and then the line cuts through it, so it looks like a little star. So that's why I call it a star point. So when I'm looking at this, if I look right here, and I will zoom in, if I look right here, this point is not a star point, right? It's really hard to tell what that point is. I'd have to estimate. That's a bad point to pick. We need pretty star points. So a pretty star point would be our y-intercept right here. It cuts perfectly through it. It's easy to see. That one's great. Our x-intercept is hard to see. It would be one that we'd have to kind of guess at. But if we look a little further, look at that down here. This one is a pretty star point. Do you see how it makes that perfect star? There's no having to guess. I can look at that and I can say, oh, that's the coordinate point, -4, 0. Or -4, -1, excuse me. -4, -1. That is a pretty star point. That is easy for me to read. I can read it easily. That's what I mean by pretty star points or by star points. So now that I have my star points, I am going to rise and then I am going to run. So I'm going to start at my intercept. Remember, we go up and down first. So I end up going down 1, 2, 3, and now I'm on the same level. All right, I'm on the same level. So this is a down 3. And then I have to go left 1, 2, 3, 4. Left 4. Well, wait a second. Down is negative, so that'd be a -3, and left is also negative, so that'd be a -4. So that means my slope is really -3 over -4. Wait a second. Negative and a negative make positive. So this is a positive 3/4 is my slope. Positive 3/4 is my slope. Some of you might have picked this star point right up here, right? There's a pretty star point. It's a little harder to see, but it's there. So that one works as well. And you would go up 3 and right 4. So it also works. Ooh. I'm going to zoom back out. Sorry you couldn't see that for a second there. I was so focused on my star points that everything else got a little lost for a second. All right, so now that we have that, let's write our equation. We know what our intercept is. We found our b. We know what our slope is. We found m. So now we need to put them together. We would get y equals, our m comes first, so that's 3/4 x. And then our b comes next, which is a positive 2. So 3/4 x plus 2 is the equation of this line. Let's do another example. If you're someone who's struggling with slope, I'm going to show you another mental trick that might help for remembering it. We would describe this line as a positive line, right? So we know that our slope should be positive. So that's good. So for our next one over here, again, we're going to pick some pretty star points for our slope. Let's start with our intercept, though. So our intercept would be right here on the y-axis. So that is the point 0, -2. So that means b is -2. That is our y-intercept. So now we need our slope. So we have to pick another star point, pretty star point. So I'm looking at my line here. Ooh, this one has lots of beautiful star points to choose from. It doesn't matter which one you pick. Okay, so I'm just going to pick one. You should try it with a different one and see if you get the same answer I get. So I'm going to pick this one down here. That's my pretty star point. You see how it lines up perfectly and it makes a little star? It's gorgeous. So this is at the point 2, -4. And now I need to figure out my slope. So it's rise over run. In this case, that means that I am going to go down 2. So we go down 2. And then I need to go right 2. All right, right 2. So that would be down is a negative. So that would be -2. Right is a positive. So that'd be +2. Here's the other way of doing that. If you were to go into a building, maybe like a doctor's office or someplace in downtown Seattle, right? If you went in there, you would have to go up and down the elevator before you could walk across the floor. Okay? So if it helps your brain, that's why we always go rise over run, because we have to go up and down the elevator before we walk across the floor. If that doesn't help your brain, that's all I got right now. But if you have a different analogy that works for you, let me know. I'm always interested in more memory tools that help us to remember the order of things. So with this one, we end up with a -2 divided by a +2. Well, negative divided by a positive is a negative. 2 divided by 2 is 1. Haha, he's a ninja, always. So we know our slope. Our slope is a -1. So when I write this equation, I'm going to have y equals -1x, and then our y-intercept is a -2. Now here's the thing, I can actually rewrite this. Because 1 is a ninja, this is also, or really, y equals -x minus 2. Okay? Usually big ideas is okay with you typing in a -1. Sometimes it has finicky issues, as we all know, because he's just special like that. So we've got 3 more examples. Our next example is, there we go. Oh, and there's some practice problems. All right, so try some more. Our next example is using points to rate equations. So we have our y equals mx plus b. First thing we're going to do with this guy, I like to just start off by finding my slope. Okay, so with these guys, I think it's easiest to start by finding the slope. Some of you might notice that one of those points is special, and we'll come to that in a minute. So let's start with our slope. We have rise over run. That really doesn't help us in this case, though, because we don't really have a rise and a run. We have points. So we need to do our y1 minus y2 over x1 minus x2, or y2 minus y1. The order doesn't matter, okay? What matters is that these points end up on top of each other, all right? So when you look vertically, that should be 1 point. So here we go. Let's try this out. I'm going to do my x's in pink, and I'm going to do my y's in orange. So y1 minus y2 over x1 minus x2. We have 1 minus -4 over 2 minus 0. And again, this is what I'm talking about. So this point right here, those two numbers are together, so they should be vertically on top of each other. Hey, look at that. 1 and 2 are vertically on top of each other. And we do want the y on top, so that looks great. So I'm going to rewrite this now with my 1 minus a -4 is really the same as 1 plus 4. And then 2 minus 0, so that's really 5 over 2. So that is my slope. My slope is 5 over 2. And then I want to find my y-intercept. Well, remember, this y-intercept is a point, okay? It's a point where the x value is 0. Hey, look at that. We have a point where the x value is 0. That means my y-intercept is -4. So b is -4. So when I go to write this, I'm going to have y equals 5 halves x, because that is my slope, is 5 halves, and then minus 4, because -4 is our intercept. Okay. So let's take a look at this one right here. And we'll get to cases where we don't have our intercept, but I want you to get into the habit of recognizing which one's your y-intercept. So this one over here, let's just start by looking at our y-intercept. Does one of them have an x-coordinate of 0? Yes, it does. It has this one right here. So that means my y-intercept is 2. So now let's calculate our slope. So we'd have y1 minus y2 over x1 minus x2. Y1 I'm going to pick to be 5. So I do 5 minus 2. And then my x1 would be -4 minus 0. And again, this is what's really important. This point should be on top of each other. And it is. Those numbers are on top of each other. So we're good. So 5 minus 2 gets us 3. -4 minus 0 is a -4. I'm going to rewrite that as a -3/4. So when I go to plug this into my equation up here, I am going to get y equals -3/4 x. And then what kind of a 2 is this? Positive. So plus 2. All right, I'm going to flip to the other side. Here are some practice problems, page 100 in the student journal, 13 through 15, or 18, excuse me. All right, linear functions is the next one. Linear functions. So you know what function notation is, okay? You remember it. That's when we have coordinates. So if you have f of x equals some number, you can turn that into the point x and that number. So I just want to remind you, f of x is the same thing as y. Okay, don't get weirded out. It just helps us. It puts the fun in function notation. So here we have our function notation written as f of 0 equals 10 and f of 6 equals 34. First thing we're going to do, because I know it's going to be helpful, let's just turn those into points. So this one, f of 0 equals 10, is really going to be the point. And I'm going to re-highlight these for us. I've been trying to keep my x's as pink and my y's as orange. So this is really the point 0, 10, right? That's really what that point is. And then our other one here, f of 6 equals 34, turn that one into a point. Take a minute, turn that one into a point. Okay, you should have gotten the point 634. So now that we have our 2 points, now we can find our slope. So our slope we know is rise over run, not going to be super helpful. So let's do y1 minus y2 over x1 minus x2. Our y1, doesn't matter which one you pick. If you really don't like working with negatives, go with the bigger one first. So let's do 34 minus 10. And then we are going to do 6 minus 0. So we have our x's in the denominator. We have our y's in the numerator. And we end up with 34 minus 10 is 24. 6 minus 0 is 6. 24 divided by 6 is 4. So that is our slope. Our slope is 4. Well, now we need our y-intercept. Wait a minute. The y-intercept has an x-coordinate of 0. Do we have that anywhere? Yes, we do. Right here. This is our y-intercept because the x-coordinate is 0. So that means b is equal to 10. So when I go to write this equation, we have our y equals mx plus b. So here's b, and here's our slope. So we would get y equals, our slope is 4, and our y-intercept is 10. So we would get y equals 4x plus 10. All right, y equals 4x plus 10. There are some problems to try on page 100, number 19 through 24. I'm going to post some more extra practice for this as well, because it is really important. All right, our next one on here, this is a real world problem, ooh, aka word problem. So we've got excluding hydropower. U.S. power plants use renewable energy, 105 million megawatt hours of electricity in 2007. By 2012, the amount of electricity generated had increased to 291 million megawatt hours. We want to write a linear model. So a linear model is a function that models a real life situation. And we're going to use the form y equals mx plus b. So that means we need to find our slope and we need to find our y-intercept. We want to find the megawatt hours generated by non-hydro renewable energy sources as a function of the number of years since 2007. So use the model to predict the number of megawatt hours in 2017. So this was a couple years ago. So here's what we're going to do. There's a lot of numbers being thrown at us. We're just going to sit here and go, okay, what's important? What do I care about? And I'm going to take my yellow highlighter and just highlight what we care about, okay? So starting off here, we know that we've got 105 million megawatt hours in 2007. That's the first thing. The next one is in 2012, they'd done 291 million megawatt hours. 291 million megawatt hours. So we want to know that everything is being compared to 2007. So we're going to set that as our 0 mark. All right. All right. Everything compared to 2007. So that means this will be our 0. All right. X is everything after 2007, or I should say every year every year after 2007. So if X is 1, that means it's 1 year after 2007. If X is 10, then it's 10 years after 2007. If it's 100, then it's 100 years after 2007. So that means Y is our megawatt hours. All right. And let's just call it our million megawatt hours. Just make ourselves easier, way easier that way. So if we write a function, it would be f of the years since 2007. And it's going to equal some amount of megawatt hours. Are we so far together? Okay. So the next thing that we want to do is they've given us some numbers here. So we know that in 2007, there was 105 million megawatt hours. Well, 2007, we already said was going to be our 0. So 2007 and 105 million megawatt hours. We would translate to being 0 for our X and then 105 because we're going to ignore that million for now, right? It's going to be way easier. The next one they gave us was in 2012. There was 291 million megawatt hours. So let's translate that into, well, how many years since 2007 is 2012? That'd be 5, right? So this would be 5 years since 2007 and 291. So 5 years since 2007. So now that we've got 2 points here, we can find our slope, right? We can find our slope. So our slope is y1 minus y2 over x1 minus x2. I'm going to use my orange again for my y's, and I'm going to use my pink again for my x's. It doesn't matter which one comes first. I'm going to start with 291 minus 105 over my 5 minus 0. And again, just make sure when you look at this vertically that this is 1 point, and sure enough, it's 1 point. So those match up great. So now when I do that subtraction, we end up with there we go. 114 over 5, which is 22.8. All right, 22.8. Next thing we need to find is our y-intercept. What is our y-intercept? Well, wait a second. This has a 0 for its x-coordinate. So this is our y-intercept. So that means that b is going to be equal to 105. So I'm going to use y equals mx plus b. We know our slope. We know our y-intercept. So we would get y equals 22.5x plus 105. That is our linear model. That is our equation. That is our function. The last thing it asked us was we want to figure out or predict how many megawatt hours would be generated in 2017. Well, 2017 is 10 years after 2007, right? 2017 is 10 years after. So that means we would have to plug in 10 for our x. So we're going to plug in y equals 22.5. There we go. Plus 105. So we get y equals 22.5 times 10 plus 105. When I do that, we get y equals 225 plus 105. So y equals 330. So in 2017, our prediction says that there would be 330 million megawatt hours. Yes, you should write that sentence out. No, I do not have room on my page to write that sentence out. And we could even rewrite this, just so you know, as a function with function notation. So f of x equals 22.5x plus 105, which means this would be f of 10 is equal to 330. So that would be the function notation form of it. So 10 years after 2007, there were 330 million megawatt hours produced. Hopefully. I hope this makes sense. Please shoot me an email if you are stuck or struggling.